first thing that I want you to do, right on the front, everyone sees where it says day 1. My goal today is to get through packet pages 2 through 5. And right next to it, here's the assignment I'm suggesting for tonight. And again, suggesting. I'm not looking at it tomorrow. Everyone still has the January 2020 exam, the actual paper copy, the only one I've given you. Everyone knows what I'm talking about. We've been working a couple problems out of it. My suggestion tonight is finish the part 1s. Okay, finish the part 1s. Okay, finish the part 1s. We've done a bunch of them already, but finish the part 1s. That's my suggestion tonight. January 2020, finish with the multiple choice questions. I will go over anything you want tomorrow. Okay, so if you try a couple out and the video solutions don't do it for you, the work I put on Classroom doesn't do it for you, ask me tomorrow first thing in class. All right, so January 2020, finish the part 1 for me. All right, let's get reviewing. Here's what I did. I went through all the old Regents exams and I started to notice a pattern. There's certain topics that you can probably guarantee that'll be on there. All right, and that's what this packet is right here. Topics that you can probably expect is a good bet. In 2 weeks, you're going to see that type of question. All right, so here we go. First one, usually they'll ask a question about rotating a 2-dimensional object and what 3-dimensional figure do I get back. Okay, so in this case, this first problem, I'm taking a rectangle and I'm rotating it around W. So here's what they mean. You got side W, and it's going to stay there, but I'm just going to continuously pretend you're holding on to line W and rotating that rectangle around and around and around. What shape is it going to end up forming? What polyhedron, what 3D object am I going to end up forming? Romeo, start it off. It's going to be a cylinder. Yeah. Everyone can visualize that. I rotated all the way around. It's going to be a cylinder. And then what about the one right below it? Some of these go quick here. What if I just have a triangle now and I want to rotate it around the flagpole? So AB staying right where it is, rotating that sucker all the way around. What am I going to end up with here? A lot of numbers here, a lot of numbers. Like you got to check my background now. Okay, here we go. 13. Cone, good job. That's a cone. All right, just some other ones to be aware of. I have rectangle, that was a cylinder. Right triangle, Lucy just told us that was a cone. Half circle, if you rotate that around, that's a sphere. And the other one I saw the other day was this, a quarter circle. So let's add that in. If I'm asked for a quarter circle, so just to give you a visualization what I'm talking about here. If I rotate, let's say I rotate that quarter circle around the y-axis, what am I going to get now? Hemisphere, yep, hemisphere. Okay, that's a hemisphere. All right, so probably a good bet we'll see one of these rotation questions somehow. All right. Anything? Ask away, because I'm going to jump around topics now. Always parallel and perpendicular line questions and slopes. Always. Slope of a line is -1/3. What's the equation of a line that is perpendicular? Right. 2 lines are perpendicular. Slopes. Slopes, what do I have it? They are, what's the term we use? Slopes are negative reciprocals. And you guys are starting to see I put a little what I call guidance to the right to help you guys out when you go back and start formally studying for all this. Negative reciprocals, which means flip it and change the sign. So here's my question to somebody right now. If my slope is -1/3, what's the slope of the line perpendicular if it's the negative reciprocal? Negative reciprocal. Flip it and change the sign. What's my new slope? 5. Jackson, what's my new slope? Flip it and change the sign. Positive 3. So I'm looking for something right now out of these multiple choices that have a slope of positive 3. And they're going to make it tough on you because everyone noticed none of those equations are in y equals form, are they? None. So you're going to go through right now, get them into y equals form for me, and figure out which one of those has a slope of positive 3. Positive 3. So get each one into y equals form. And remember, the slope is the one next to the x. You're looking for the one that's positive 3. Find it. Which one comes out to be positive 3? 13? 3. Good job, Melissa. Good job. If you guys want to see where she got that, 9x minus 3y equals 27. I subtract 9x over and divide by negative 3. And when you do negative 9 divided by negative 3, that's where the 3x comes from. All right, good work. Last thing before we move on, I want to make sure all our bases are covered. What if I change this word up here to parallel? What if we change it to parallel now? What do you know about the slopes if they're parallel? It's got to be the same. So now I would be looking for a slope of negative 1/3 again. All right. They're going to test you on your parallelogram properties. Parallelogram, rectangle, rhombus, square. I'm not reading these off to you. All right. I do want to add one into the rectangle, though. I do want to add a fourth property in for the rectangle. And it has to do with their diagonals. The diagonals form four isosceles triangles. Okay. Let me just show you real quick why that's useful if it comes up. If you have a rectangle, everyone see the 4 triangles I'm talking about? It's isosceles, which means what's across from those congruent sides I just marked. Okay, that's why I want you to know that property, because those angles across are congruent too. All right, these two are equal right here. All right. All right, go through these with me. This is where you could see it. Parallelogram must be a rectangle if, know the property. Look at the properties of a rectangle right now. I have a parallelogram. It must be a rectangle when, remember, I want something that's specific to a rectangle, not a parallelogram. I know it's a parallelogram already. So what's going to make it into a rectangle? Because 2 of these up here are parallelogram properties. All right, I don't want that. I want something that's for a rectangle. Which one's specifically for a rectangle up here? 3? 2. Diagonals congruent. There we go. Just tell me, give me my space. Got to get filled in on what these 3 are for. All right, this one we're working on right now.
Okay, thank you.
All right, and then the second one, parallelogram is always a rectangle. I should have just deleted that one because it's almost a repeat, huh, Cal? Basically asking the same thing. Parallelogram is a rectangle if the diagonals are congruent. Right. All right, let's keep talking about the quadrilaterals. What's the best name for this one, A, B, C, D? I know by looks we could probably get rid of trapezoid, right? Rectangle, rhombus, square. Like, how am I going to know which one it is? Just guess? Cripe, if they put diamond up there, I bet somebody would circle it. Even though that we've never talked about that. So how am I going to figure out, out of rectangle, rhombus, square, the diagonals? They all have something different with their diagonals, right? Rhombus, rectangle, square. So everyone connect the diagonals for me. Connect the diagonals for me right now. BD and AC, connect them. They always have something different about their diagonal. Can you tell me anything about those two you just drew in? Just look at, you drew a vertical and a horizontal line in. Can you tell me anything about them? Emma? What? They form a right angle, don't they? Everyone agree those two are perpendicular. Well, I could tell you in a rectangle, they're never perpendicular in a rectangle. So this can't be a rectangle. Done. Now we're into rhombus and a square. What type of angles does a square have in it? Right angles. Do those look like right angles to us? Can't be a square. Square has right angles. So therefore, just by knowing something about the diagonals, I could tell you it's a rhombus. Okay, so think about the diagonals if you're trying to figure out which square, rectangle, rhombus it is. All right, let's keep trucking. So you guys can read through here. They gave me something about A. I don't need to graph this. And something about C. What is AC called again? What's AC called again in my parallelogram up here? What's AC called? 18, what's AC called? Not here. That's what AC is called, yes. Good job. 2, what do I know about AC? It's called the diagonal. And this is a rhombus, or what would make it into a rhombus? What do you know about the diagonals of a rhombus? Look back at your sheet if you need to. We just went over it too in the previous problem. The big one about diagonals of a rhombus are 4. Okay, thank you. Thanks. Appreciate that a little quicker. 6, diagonals of a rhombus are perpendicular to each other. All right, so if this is going to be a rhombus, AC's got to be perpendicular to BD. What did we just go over? When do I know two lines are perpendicular? Slopes are negative reciprocals. So the first thing we need to figure out is, what's the slope of AC? How do I do that? Oh, slope formula. Is that given on the formula sheet? Nope. Open up your packet. Let's go. Cold hard facts. I'm going to force this out of you every time I need something. Slope formula should be in there. I believe it's right on the first page. You don't have to go far. You got your distance, midpoint, and slope all in one spot. Everyone see the slope formula? Changing y over changing x. Here we go. y2 minus y1 over x2 minus x1. And go ahead, plug your y's and your x's in, and I'll talk to somebody here in a second. You got A and C to plug in. Y's on top, x's on the bottom. And I'll ask somebody what they found the slope to be. When you get the slope, let me know. Jackson, let me know when you get the slope. Subtract your y's and then subtract your x's. 3, good. Positive or negative, be careful. -3. So if AC's got a slope of -3, DB has to have a slope of, if they're going to be perpendicular, negative reciprocal. 11. Positive 1/3. So diagonal BD has to be 1/3 if it's going to be a rhombus. Good work. Can't do that problem unless I know my properties. And I know it's only day 1 of review, but we got 2 weeks. Got to know my properties. And let's keep talking about a rhombus. Go ahead and graph what I have here. I gave you a little piece of graph paper. M is 0, -1. And T is 4, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. T, got it. I'm asking for a little more in this one than the last one. I'm asking for a little more. What I want is where I don't know. I don't care what A and H are, but I do want to know what's their equation. What's the equation of this line right here that has A and H on it? First thing, give me the slope. Give me the slope of AH. We can do this, right? Give me the slope of AH. Find the slope of MT and take the negative reciprocal of it. Go ahead, and then I'll help you out from there. Because it's a rhombus, I know the diagonals are perpendicular. So find the slope of MT for me first. Yep, we'll get there in a second. Yeah, you're going to need your calc for this one. The crappy numbers on this one. When you get it, let me know. Your slope of 2 when you're ready there. I like it. Positive 7/4 is the slope of MT. So what about AH then? It's a rhombus. Diagonals are perpendicular. So if the slope of one, 7/4, the slope of the other one. 3? -4/7. Good. Nice work. But I need the equation of the line. Equation of it. And for you guys, when you write the equation of the line, we need 2 things. 2 things. One you already found me. What's the slope of this line? -4/7. Now you got to find the B, the y-intercept. That's what we need. You need the slope and you need the y-intercept. How do we get the B value? I plug everything I have into y equals mx plus b. And you're going to solve for the B now. What's one thing we already have? What's one thing we already know about this new line? Slope. Plug it in for m right now. -4/7. Now I need an x and a y to plug in. Hey, and that x and y has to be on that line. Now, I don't want m or t. I want an x or y to plug in right here into AH. You ready? How we're going to find that point? It's a rhombus. Diagonals are perpendicular. And what are they doing to each other? Thank you. Bisecting. Which means they're going to have to go through each midpoint. There we go. So we're going to have to find the midpoint of MT. Ooh, midpoint formula. Look it up. It's right there next to distance. And apply it to MT for me. Find the midpoint of MT. X is divided by 2, y is divided by 2. That'll be a point on there that I can plug into y equals mx plus b. It's okay to get decimals. When you have the midpoint of MT, let me know what you have. 11 ones when you're ready.
Did you say 11?
Yes, I said 11.
2 and
2, 2.5. That is a point on AH as well. So I could take its y and its x and plug it into y equals mx plus b. So what was the y coordinate you just gave me, Zach? So 2.5 equals slope. What was the x coordinate you gave me, Zach? 2. And now we're going to solve this together for b. And then I'll put the 2 together and write the final equation. 2.5 equals, this is why you had the calcs with you, negative 4/7 times 2. Anybody getting out negative 8/7? Or maybe the decimal version, whatever that is. And then how do I get b alone? Oh, no, I'm not multiplying by squadoosh, nothing. This isn't negative 8/7 times b, it's plus b. So how do I want to get rid of this? Add it over, because it's negative, right? So add it over. Try to leave your answer as a fraction here. I know it's not the best fraction, but hey, I told you it was going to be a little crappy here, but what do we got? 51/14 for the b value. Put all our work together now. Give me the final equation of AH. Y equals, put them together now. Slope and y-intercept. Put them together to write the equation. Jackson, 5 on fire today. Y equals, what was our slope? 4. That was m value. That was our slope, 4/7. Okay, negative 4/7 x, and then what did we just find the y-intercept to be? Our b value. What did we just find it to be here? Plus 51/14. Not the greatest. Probably won't be that extreme, but slope, y-intercept. You got to write the equation line. You need those two things. Slope, y-intercept. I'm going to do one more with you, and then you can start on the multiple choice in the Regents exam. Angle R, $1.24. AF congruent to DF. Find what AFB is. And this is a parallelogram, remember. Fred is a parallelogram. All right. Whoever's up next, whatever number pops up here, give me any angle you want. I do not want the final answer yet. Give me any angle you are confident in, you know. That is a parallelogram. Properties of a parallelogram, look back if you need to, but give me an angle you are confident in. Oh, 12. Good. In a parallelogram, opposite angles are congruent. Great job. Give me another angle now. You can use that 124 or the original one. Give me another angle you're confident in. Oh, Jackson, 5. Come on. 56 right up here. Consecutive angles are supplementary. We're getting there, right? We're getting there. We'll get there sooner or later. Give me another angle you're confident in. 11.
DA is 56.
Okay, 2 ways you know that's 56. These are linear pairs. And anybody remember these type of angles? Alternate interior. Good. Keep going. Another angle you know. 13.
RED is 56.
This guy, this girl here. 56, yes. Opposite angles are congruent. How about another angle? 10.
FAG is 56.
In a triangle, in a isosceles triangle, what's across the congruent sides? Congruent angles. And now I think you've found everything you humanly possibly could, except for AFD, which will be 16. What is it? 68. There we go. Questions? Okay, I think that's a good spot to stop because the next stuff is similar triangles for tomorrow. Again, this is stuff you're going to see a lot of. Get out the exam. Let's get going. I'm not wasting any time or packing up early. Get out your January 2020 and start working on some multiple choice. Everyone knows where the answer key and video solutions are now. I will answer questions first thing in class tomorrow on those multiple choices. January 2020, the only paper copy you have, multiple choices.